Thunderstorms, the typical weather forecast on a lazy spring afternoon. In any given minute, there are more than 1,000 thunderstorms happening on Earth. Beautiful and photogenic, but these storms deserve respect. They contain as much energy as an atomic bomb. A really severe storm can dump heavy rains, damaging baseball-sized hail, deadly lightning, and violent tornadoes. Hello, and welcome to this summer edition of CU Science Update. I'm your host, Dorian Smith. In spring 2010, researchers, professors, and students from CU embarked on a 6-week storm chase across the Great Plains. They joined scientists from a dozen other universities in a project called Vortex 2, which stands for Verification of the Origins of Rotation in Tornadoes Experiment 2. They traveled hundreds of miles across Colorado and neighboring states looking for the most powerful of thunderstorms, the supercell. It is these storms where tornadoes are likely to be found. A tornado is defined as a violently rotating column of air extending from the thunderstorm to the ground. They form when air is moved upward, usually due to surface heating. This process is called convection. Tornadoes move with the storm, typically along a southwest to northeast path. During the spring, thunderstorms capable of producing tornadoes form along what is called a dry line. It's a line that separates cool, dry air from warm, moist air, and is an important factor in the frequency of severe storms. In the U.S., dry air collides with warm, moist air driven up from the Gulf of Mexico. The line typically happens in the spring, extending across the Plain States, from Texas north into South Dakota. The location of the dry line is where we see some of the highest numbers of tornadoes, a region that has been called Tornado Alley. The winds generated by a tornado are extremely violent. They can damage or level anything in their path. Tornado intensity is measured on the Fujita scale, named after storm researcher Professor Ted Fujita of the University of Chicago. The scale ranges from F0 to F5 and is based on the damage caused to buildings and vegetation. Better predictions of tornadoes can help save lives, which is why every spring storm chasers caravan across the plains armed with an assortment of various weather-finding technologies. A key instrument in locating and tracking severe storms is Doppler radar. It uses satellites to detect air movement toward and away from the radar. Vortex 2 employed 10 mobile radar trucks called DOWs, or Doppler on Wheels. These vehicles help the team get the most precise and up-to-date information on developing storms.
2, 1.
And not to be outdone on the ground, a team of CU engineers launched an innovative aircraft as part of a project called the Research and Engineering Center for Unmanned Vehicles. They used a 12-pound unmanned aircraft with a 10.5-foot wingspan to get up close and personal with some of the most intimidating storms.
At the T to 88, go ahead and turn around.
Instruments on board the aircraft are capable of gathering thermodynamic data between the ground and the larger area of the storm's base. This information is in high demand because it will help scientists better understand the convective elements needed for a tornado to form. The propeller-based unmanned aircraft is controlled by operators who send the aircraft to areas of interest beneath the storm. These planes can fly up to 1,000 feet in the air, reach speeds of almost 80 miles per hour, and last for up to an hour. The other CU team was led by Professor Katja Friedrich of the Department of Atmospheric and Oceanic Sciences. In partnership with the University of Florida, Dr. Friedrich's team deployed instruments capable of measuring precipitation in the path of severe storms. CU Science Update's Elly Collins joined the CU Vortex team and files this report from somewhere in Nebraska.
Imagine this outside your house. Would you have enough time to get to shelter? Early warning systems can alert people minutes at best before a tornado rips through town. When it comes to this monster, waiting for the sirens to go off may not cut it.
The National Weather Service has issued a tornado watch for this region of western Nebraska. Now, Vortex 2 has been monitoring this supercell all day. They hope to get ahead of the storm and deploy their instruments right in the storm's path. They'll then use this information to help improve early warning detection systems.
The CU team, in partnership with the University of Florida, joined with over 100 other scientists and 40 support vehicles in one of the largest and most ambitious efforts undertaken to understand tornadoes.
I recognize, and I think all our team members recognize, how important this type of work is, because without this kind of field research, there's really no way that we can improve the warnings that we get to the public. And that's what this entire project is all about, is ultimately saving lives and property and protecting people from these storms.
Vortex 2 is a $10 million effort to chase storms. The project is supported by the National Science Foundation and the National Oceanic and Atmospheric Administration, and led by the National Severe Storms Laboratory. Participants include over a dozen universities, all looking for that perfect storm.
I'm just gonna hope, like, I'm gonna take this out, you know, and move everything left.
The CU team of mostly grad and doctoral students was led by Professor Katja Friedrich of the Department of Atmospheric and Oceanic Sciences.
This is a pretty good looking storm right here. At the moment, there's not really any strong rotation, but there's a lot of hail.
Grad student Kalina knows all about storms from textbooks. But this is the first time he's experienced this force of nature firsthand.
The first time that we actually deployed on a storm was really the first time I had ever seen a supercell thunderstorm out here. And we were out here in this rural area up in Texas, and there weren't any buildings or houses around, so we weren't concerned that the storm was going to do any damage. And you could just watch as the rain progressed across the road and reached us, and we got hailed on, and it was just really incredible experience for me, because I had never seen a thunderstorm like this before with so much open space around it.
Each of the Vortex teams are assigned to collect data on certain parts of the storm. The CU's team's first priority was to measure precipitation. Their aim? To get in front of the storm and deploy instruments that measure rain and hail.
Thunderstorms don't wait for anybody, and we need to be pretty quick. Our team can deploy all our instruments, which are 7 instruments, in 10 minutes or less. We just need to know where to put them, and we can get them there quickly.
To get in the right position, the CU team has found themselves under the most intense part of the storm, sometimes going up against hail as big as baseballs.
Our windshield has just been broken in 3 places by golf ball-sized hail. We deployed in front of the core, but we couldn't get out in time because we're stuck behind the friggin' weather channel. All right, nice. The other truck's windshield is also broken. Oh well.
Well, we do have helmets. We haven't needed to use them yet, but we brought them on the trip, and of course we all got our rain gear, favorite raincoat on to keep us dry out there, and as safe as we can out in the elements.
Go ahead to this morning, and this morning we got the big wave is further east. It is moving fast.
The chase day usually starts off with a meeting led by the principal investigators. They discuss the likelihood of where and when storms will form that day. A location and route is then selected, and each team rolls out. It might take a couple of hours or more to reach the target areas. But then the team might have to wait longer for the storms to start up. Most storms don't usually start until mid-afternoon or early evening, which gives the crews plenty of time to play ball or work on their tans.
The funny thing about storm chasing is that it's a lot of rushing and waiting. So right now, I mean, we rushed out of the hotel because we thought it is early initiation. Go to your target area and then you sit and wait, and sometimes you can sit for hours. And then suddenly they say, okay, we have a target storm, and then you have to rush to the target storm. So it's either it's rushing or it's sitting down and waiting.
But then it's off again. The game can turn dangerous fast when the storm chases the chasers. In early June, the CU team was caught in the storm's core in Scottsbluff, Nebraska. Taking shelter is the only option to avoid being pummeled with hailstones like this. Multiple tornadoes hit Scottsbluff that day. Although weak, the tornadoes did some damage. Luckily, no lives were lost. But storms can also be awe-inspiring. Once in a while, the teams might stumble upon picturesque views that are stunning. And after a successful deployment, just sit and take in the sights, including some intense hail fog. The data they use during these 6 weeks will be used to better predict tornadoes. Studies like Project Vortex could lead to accurate warnings with lead times 30, 45, or 60 minutes. As the CU team's trek across Tornado Alley comes to a close, their research on precipitation will contribute to the overall improvement of understanding how tornadoes form. But before all that number crunching, there's still time for those wondrous sights. That is, the awesome form of nature.
Fresh from their storm chasing, we are pleased to have 3 members of CU's Vortex 2 team join us here in the studio. Team leader Dr. Katja Friedrich and grad students Evan, Kalina, and Stephanie Higgins. They sat down with CU Science Update's Rachel Dubrovin to sum up what they saw in their 6-week journey.
The first thing that really stands out in my mind from Vortex 2 is the first time that I've really seen one of these supercell thunderstorms that we were working with. And we're in a really rural area, so you could see for miles around. There was nothing but fields. And as the storm moved across, you could just see this sheet, blinding sheet of rain and hail moving towards us. And it's just this incredible thing because these storms are huge, and you really get a sense of how powerful they are when there's really nothing but you and the storm out there on the plains.
Yeah. Do you ever get like scared, or are you always just like really excited and you want to chase the storms, or are you always ever like a little bit nervous to go while these are?
You know, we weren't scared, but I think the Weather Channel was really scared because we lost our windshield in hail, and we really could only see out of this circle. It was about this big, and it was kind of over to the sides. We're driving over here, looking through this little hole, and everything else is smashed. And we're trying to get out of the hail, and we're trying to pass the Weather Channel van, and they're going about 20 miles an hour, and we can't get around them, and we look in, and all of them are sitting there with towels over their heads, holding them up to the roof, and the driver's wearing gloves, and they just look absolutely petrified. So we just blew right past them, and we were fine, but I guess it was a little scary the first time.
The adrenaline definitely pumps when you're out there. I mean, when you see tennis ball sized hailstones falling out of the sky, I'll admit that I was a little scared, and I'm not ashamed to admit it, because these storms are powerful.
I think the lightning was the scariest part.
Lightning.
I think when lightning hit a telephone pole right next to the truck, that was for me the scariest moment.
And there's no way that you guys are protecting yourself, or no?
Well, we don't get out of the car.
I mean, we're in the car, so first thing is we're relatively close to the area where the tornado forms. So then, every time I do these instructions over the radio, I'm trying to be calm and just make the impression there's nothing to be worried about or to be scared. I mean, sometimes I look at the radar image and like, oops, so we should better get out. So, but it is, we are really close to the main part of the thunderstorm, and we're also very close to the area where the tornado forms. And sometimes you see these supercells, they're moving very, very, very slowly, and then in the next radar image, 5 minutes later, they speed up, and you don't really account for that, so then we have to hurry up. So it is, it's not frightening, but sometimes it's a little bit scary. from the safety perspective, maybe most of the time we are in the car. So even if we have big hail, or then I mean we are still safe in the car. You have a broken windshield, yes, maybe you have some glass falling to us, but I mean generally your life is safe. It's nothing that you need to worry about. And also from the tornado, most of the, if there's a big violent tornado, we might not would have deployed, but most of these tornadoes are relatively small ones. So even if the wind velocity is like whatever 35 meters per second, I mean this is wind velocity that you also encounter in Boulder, so this is not really scary. But the entire environment is very scary because it's very dark, you have hail, you're in the middle of the road, and you don't really know where you're driving into, and that's, I think it's a little bit scary. But nothing really has happened, and I hope nobody really...
No one got hurt on Vortex either year, I think.
That's good to hear. Were there any like hot spots for storms this summer that you guys found, like maybe Oklahoma or somewhere else that was like had an exceptional amount of activity? Or
I don't think so. We were driving. We drove in total. We drove 15,000 miles in 6 weeks, and we were all over the place. We were in Texas, in Kansas. I think we never really had a hot spot. We drove from Texas up to, we were in South Dakota, and then we were in Wyoming. So and actually all the states that are more or less in the Great Plains.
it all looks the same kind of, huh?
Actually, it was really different. I have a geology degree, so I thought it was really exciting. I don't know that much about the weather, but I was so excited to drive past all the different bluffs in North Dakota, and then through by the Missouri River in South Dakota.
Oh, awesome. Now, what kind of data did you guys collect again?
So we basically were looking to determine what the drop size distribution inside these thunderstorms were. And what that means is we use these instruments called disdrometers, and they have a little laser between 2 parcels, and they detect the size and the fall speed of each raindrop that passes through them. So in the end, when you put all this data together from each of the thunderstorms, you get this nice curve that's called the rain line, and it shows you exactly how fast and how large each drop was that was falling from the thunderstorm.
Great. Now, now that you collected all this information and you brought it back to Boulder, what are you guys going to do with it? Do you know?
Evan is supposed to write his PhD thesis.
Well,
go ahead.
What we'd like to do is sort of compare the data that we've gotten from the disdrometers to the radar data, because the other teams that were on Vortex 2 also provided us with radar coverage over these thunderstorms. So you can basically compare the intensity of the precipitation that we're recording from our instruments with those that the radars are seeing.
So basically what we're trying to do is to get an understanding of what are microphysical processes within these supercell thunderstorms and how they actually affect the formation of tornadoes. So how much hail do we have in these storms? How big are the raindrops? What is the process of melting hail? How does it affect the environment? How does it cool or warm the environment? How does it change the humidity? And temperature and humidity are really important quantities that determine whether this storm actually produces a tornado or doesn't produce a tornado. And so that's our main research interests, and that's how we collected the data and how we actually relate this also to the radar information that we got.
Awesome. So will you use it when you teach other classes at CU?
Sometimes I use it. What I'm usually trying to do is to also trying to teach my students or give them an understanding what it means to be out in the field and collect these data. So we come up with a result, but I mean, really starting from the first day where you go out, you have a hypothesis you got, what kind of instruments do you take out, how do you design an experiment, and then also to show them different kinds of instrument that we are using. How does the data look like, and how do we come from the data that we collected to our research results. So yeah, I use a lot of this information in the field, and usually, especially if you have an exciting project like Vortex 2, I mean, students are very, very interested. How is it to be out there? How is it to do measurements close to a tornado? Is it dangerous, and so on? So we do a lot of these kind of experiments in hurricanes and tornadoes in winter storms. So
that's actually how I started working with Katja. I was in a class, and I was just sitting in this class, and she came and gave a talk and had this slideshow about hurricane deployments, and I was just like, so I actually switched advisors after that.
Because that's an important factor that students have to understand how difficult it is to do these measurements and also what it means to have high quality measurements, because we talk a lot about climate change, temperature, humidity, but what does it really mean to measure temperature, and how reliable is our measurement? So that is a very, very important factor that I'm trying to teach throughout the levels, if it's undergraduate or even if it's graduate classes.
That's great. I also wanted to ask you guys about our current severe weather warning and watch system that we have. I heard it's really inaccurate. Do you have any opinions on how we can make that better?
I wouldn't say that it's inaccurate. I would say that it tries to optimize the number of times that when you do have a threat out there, that you do warn people about it. So in essence, there's a lot of false alarms, but there are not many events that happen that don't have a warning issued for them. And one of the ways that Vortex 2 sort of seeks to improve the watch and warning system is to try to determine ahead of time what thunderstorms are tornadic, what aren't. What can we look for in these storms that will tell us ahead of time about whether they will produce a tornado, so we can narrow down the number of false alarms that are out there.
Yes, so far the false alarm rate is like 70%. So most of the times you give an alarm, but it did not produce a tornado. So one objective of Vortex 2 is actually to decrease the false alarm rate. And also usually the time between the warning and the event, like the tornado, it's usually 10 to 15 minutes. So this is also another objective of Vortex 2, to increase this time, to give people more lead time, more warning time, or time to react. So decrease the false alarm rate and increase the lead time. That is an objective of Vortex 2.
That's amazing. Awesome. Well, I also wanted to ask you guys one final question. If an amateur storm chaser who had interest in this kind of thing came to you guys for advice, what kind of advice would you be able to give them?
Well, it is dangerous, and you do have to be careful when you're out there. I guess what I would say is that you want to always be safe, especially in terms of when you're chasing storms. You have to keep your speeds down, and I think that the most important thing would be to do it with someone who's experienced, who has done this before, because it is very dangerous out there, especially if you don't know what you're doing.
Yeah. Well, thank you guys so much for joining us today. I really appreciate it.
Thank you
for having us.
When the National Weather Service issues a tornado warning, that means a tornado may be fast approaching. The warnings are issued when a funnel cloud is spotted or the radar indicates that a tornado may be possible. When a tornado warning is issued for your area, go to the lowest part of your house and to the center of the room to avoid windows. A bathroom or closet under a stairwell or interior hallway may also be used. If you're in a car or truck and the tornado is near, seek lower ground, such as a ditch, and lie flat on the ground with your face down. Use your hands and arms to cover your head. If you're in a mobile home, your best bet is to get out, even if the home is securely anchored. We would like to thank Dr. Friedrich, along with Evan and Stephanie, for joining us, and we wish them all the best as they begin their work with the data they've collected. Thank you for joining us today, and we look forward to seeing you for our next edition of CU Science Update.